Hello guys, how have you been? I hope you're doing alright. So today we're gonna start with SAT. First of all, we're gonna learn what is SAT. We're gonna take a simple definition of it. There is an example. I'm gonna use that example to make sure that you get the idea of SAT. Then we will start with I think there is this spatial type of SAT. We're gonna check whether that spatial type of it's a collection is a SAT or not. Right? So let me just start. So first of all, what is a SAT? Right? So SAT is a collection of well-defined and distinct objects. So now we're going to take a look at some very, I think, a basic idea about this definition. When I say object, right? So object is something that is primitive. What I mean by primitive, I mean that it is something that is well understood, yet it doesn't have a proper definition. So if I have to say, if I have to establish this idea that what are objects, and to be very frank about it, I don't have a definition about object. It is something that you will learn to recognize what are objects as you will do more question as we will go further with our lectures, right? But let me just give you, suppose for the first time you are hearing about the idea of objects, let me give you some idea that what you can think of object as. Objects are generally they are numbers, right? So 1, 2, 3, 4, 5. Not necessarily natural numbers. They can be real numbers. They can be irrational numbers. Any type of number that you know, they can be object, right? But object is not restricted to only numbers. So so it can also be, let's say, emojis, right? So let's say object means is something that is primitive. So it is well understood, yet has no definition. All right. So examples can be 1, 2, 3 numbers. It can also be 4.5. It can also be root 7, right? And emojis like this or emojis like this. So they can also be an object. I think orange or apple or let's say water bottle or in the way I say it, clock, bottle, my my pen, my book, my laptop, my webcam, my keyboard, all of these are examples of objects, right? Okay. Now, when I say well defined, let me just define well defined. So what does well defined means? When I say well defined, it means that there is no ambiguity or confusion regarding, suppose I'm testing an element, right? Or element and objects, I'm going to use both of these terms synonymously. That means that I can use element or object. Most probably and most generally, they are synonyms of each other, right? So they means basically the same thing. So I think I was defining well defined. Okay. So when I say well defined, what I means that whenever I'm testing an object, right? So there is no ambiguity, there is no confusion regarding whether this will be included or excluded from the collection, right? So what I mean by that, let me define that let's form a collection. Let's form a collection like okay. So X is alphabet and X is a vowel. Now there are so many things that I have yet to teach you. So just bear with me for a little moment, right? So when I say that X is an alphabet and X is a vowel, so these are the two conditions, right? This is the condition for testing element. What I mean by that using this method, I'm gonna find out that like there is a the number of objects, possible objects are like very much large, right? So obviously I'm not gonna check every object because it's gonna take me forever to do it, right? What I'm gonna do, I will define that okay, so this is the all the objects that you need to focus on. So this information, this statement X is an alphabet gives me the idea that what object I should start focusing on and what object I'm going to test for inclusion or exclusion. And this condition is X is a vowel is a condition for um, inclusion or exclusion. That means that I'm going to use this condition to either include an testing object or either exclude an testing object. So let's see, we have X is the alphabet and X is the vowel. So what does it mean? So we will have alphabets like A, B, C, D, E, F, and so on, right? I think I should write G, H. No, I think I should just skip. Right. Now I'm gonna start with because the first information gives me the idea that I have to test all the alphabets, so I'm only gonna test the alphabets, right? So I know that A is a vowel, right? So because A is a vowel, that now remember this. Okay, I think this is more further. Right. Let me just go back to the definition and let me just define that. When I say well defined, that means there is no ambiguity regarding inclusion or exclusion. And when I say distinct, it simply means the object has to be different, right? When the elements have to be different, that means I'm not going to include two same objects in a set, right? And then we will have collection. Collection basically means that it's a collection of football players or collection of top 10 games of PS5, right? So collection basically means um, collection means, oh, I can't use the word grouping because grouping means something else in mathematics. I will just say collection. I will just say collection is also primitive, right? When I say collection, we mean that there are certain objects and you collect them. Uh, Maybe you will have a purpose. Like let's say you have all of your like this is my room, right? So this is my room. So there are so many objects in it. What I can do, I can just simply say that okay, let me form a collection of my clothes, right? So I will have all of my clothes. So collection means basically you collect them, and the idea behind this collection or to collect them is so that you can organize them based on a particular need. So right now, just say, for example, I need to make sure that I get all my clothes together, right? So what I'm gonna do, I'm gonna simply form a collection of them. So I think this is what collection means, not to dwell on it too much. So I'm gonna skip that part. So we know what is a collection, we know what is an object, we know what is a distinct object, and we know what is well defined. Now, we'll just move ahead with our example again. So X is an alphabet and X is a vowel. These are the two conditions, right? So this two signs, this and they represent this represents the start of the collection and this represents the end of the collection, right? Anything between them represents one collection, right? And this condition, testing element condition, and this inclusion and exclusion condition, they are providing me the idea of what a set will look like, right? So set itself is a collection. So whenever I have to represent set, I'm going to use the symbols for collection, say the start of the collection and the end of the collection, right? Now this two condition, if an element has to be a part of this collection, right? It has to satisfy both of this condition. That means that it has to be an alphabet and it has to be a vowel. If either of this condition or both of this condition are not satisfied, not fulfilled, then the element is not going to be part of it. Okay. Make sure that when you are making a set, you check both of these conditions are ticked, right? I'm going to start because we know A is an alphabet, right? And A is a vowel. So A is going to be part of this collection. So let me just form this connection A. Then B is an alphabet, right? So B is an alphabet, but B is not a vowel, right? C. So one of these condition is not fulfilled. So what I'm going to do, it's not going to be part of it. Similarly, C is an alphabet, but C is not a vowel. That means it's not going to be part of it. Then same goes for D. And when it comes to E is an alphabet and E is also a vowel. That means E is going to be part of it, right? And the same goes for every alphabet because we are only going to test for alphabets, right? So we're not going to include, let's say, orange or apple or my camera or my clock or my charger, right? So it's going to be A, E, I, O, U. And because we know that this is the end of our collection, I'm going to put the symbol to define that, yeah, this is our collection. So first of all, this collection is well defined because whatever the object we are choosing, we have this idea, this clear idea of whether it will be included or excluded, right? Then all the elements that I have taken, they are distinct, right? E, I, O, U, all of these five elements, yes, five elements are distinct, right? That means it checks all the three conditions that it is a connection, check, well defined, check, and distinct elements, check. So it's gonna be a set now. Okay, let me give you more example. Let's say, by the way, this form, like both of this, let me use another, I think green color. Okay, this and this, they both are set, right? And they both are equal, but there are two different ways to write them. This way is called roster form, and this way, wait a minute, no, I'm very sorry. I think this is not a roster form. Let me go back. Okay, this one, this one is called roster form, and this one is called fact builder form. So these are two ways to write a set. Roster form means that we're gonna write all the elements in it, right? Or even if it's not all the elements, we will start writing with elements in it. So there will be no testing condition, there will be no inclusion or exclusion condition. It will simply be a collection and then there will be its elements, right? And a set builder form is that it will give you a condition. You have to build the set yourself, right? The way we have X is an alphabet and X is a vowel. So it doesn't gives me um, elements. What it gives me, the condition to form the or to build the set, right? So these are the two forms. Okay, let me give another example. I'm gonna use orange again. Okay, let's start with what should I write? Let me give you a set builder form. Let's say X is a natural number and the condition again is x is between 1, let's say 7, right? So this is a set builder form, right? Now I have to form a roster form, let's say. What I'm going to do, I'm going to simply make sure that I'm testing only the natural numbers due to this condition, and the natural number which will be included are going to be this, right? Right. So let's start with, we know natural numbers are 1, 2, 3, 4, 5, and so on, right? Okay. So 1 is a natural number. First condition is checked. I'm going to test it for inclusion or exclusion, because if x is equals to 1, then this condition doesn't satisfy, right? Because when I say x has to be greater than, strictly greater than 1, then 1 is not strictly greater than 1 itself, right? This condition is not there, right? What I'm going to do, I'm going to make sure that I don't use it. Let me get a cross on it, because both of these condition has to be fulfilled in order for an element to be a part of the, I think, a set. So because one of the condition is not fulfilled, so one is not going to be part of this set, right? Let's check for 2. 2 is a natural number and 2 lies between 1 and 7. So both of the condition are true. So I'm going to start with 2, right? Then again 3 is a natural number. 3 is between 1 and 7. The same goes for 4. So 3, 3, and 4, and 5, and 6. When I'm going to check for 7, 7 is a natural number, but 7 doesn't lie between 1 and 7 strictly, right? So that means 7 is not going to be part of it. And any natural number after that is also not going to be part of it, right? So the only way and testing element will be a part of, or any element, any object will be a part of this set, is if they satisfy both of the condition. They have to be the testing element and they have to be included with respect to the inclusion exclusion condition, right? If either of those or both of those are not fulfilled, element is not going to be part of it. So let's say if instead of writing natural number, I, okay, no. Let's say I'm checking for 2.5, right? So 2.5 is, even though it lies between 1 and 7, right? Because it is not a natural number, that means what? It's not going to be part of this collection, right? And let's say uh, root, I guess root 2 is going to lie, right? Root 1 is also going to lie. Let's say root 81, but then it's not gonna be, all right. Let me think of another example. Something that is not a natural number and something that doesn't lie between 1 and 7 either. Why am I thinking about it? Okay, let's test for 0. By the way, 0 is my favorite number. So let's start with 0, right? So 0 doesn't lie between 1 and 7. Neither 0 is a natural number. Because both of these conditions are not fulfilled, that means it's not going to be part of this set or collection, right? Now, there is also one more thing I need to tell you, that generally we represent set within capital letters. So X, capital Y, capital Z, capital E, capital B, capital C. Generally you will see, or you will find out, generally we use capital letters to represent a set. And small letters like small x, small y, small z, small a, small b, and small c, they are used to represent elements of those, right? So let's say I represent this set with capital X, then 2, 3, 4, 5, 6 are its elements. So what I'm going to do, I'm going to write 2 belongs to X. This is the symbol is called epsilon, and to represent this is used to represent um, belongs to. So the symbol is called epsilon, and it is used to represent belongs to, or it is an abbreviation of belongs to. So when I say 2 epsilon x, that means 2 belongs to x. That 2 is going to be an object. Why? Because capital X represents a set, and the only thing set has are elements, right? So 2 belongs to an X. Okay, set can have many more things. So let me correct my statement. When I say 2 belongs to X, that means 2 is an object and it belongs to the set X. Okay, so we have done set, right? We have done roster form. Let me also give you one of the example. Let's say I form a collection. Why I'm saying it collection? Because I have to check whether this is going to be a set or not. Let's say collection where X is a X is a let's say PS5 game, and let's say um, X is a top 10 for everyone. Okay, now okay, why I have to check. Suppose I define a collection like this. X is a PS5 game and it is a top 10 for everyone, right? But this is set builder form, right? If I'm writing this in a set builder form, doesn't that mean that I'm already implying this is a set? Okay, let me get rid of this. Let me get rid of this. Right. I think because I'm checking for whether this is going to be a collection or not, I can't use the set builder form, right? Okay. Let me see a collection. This is not capital A. This is a collection. So a collection of top 10 PS5 games for everyone. I have to check. Suppose if I have a collection of top 10 PS5 games according to everyone, then whether that collection is going to be set or not, right? So there are only two conditions I need to check for. I already have the collection, right? So there are only two conditions I have to check for. First of all is it has to be well defined. So whenever I'm checking for an object, there should be no confusion regarding its inclusion or exclusion. Then we have that we have to make sure that we're only taking distinct elements, right? Now, the very simple idea is, let's say, according to me, my top 10 would be something like God of War, Mortal Kombat, then we have, I think, what it is called, Horizon Zero Dawn, Among Us, and there is one more racing game I forgot. Okay, okay, just forget it. I think this will be my top three, right? So let's say I choose a game like Mortal Kombat, right? There is fatality, there is brutality involved in it. So it is not for everyone, right? So there will be people who will say that, okay, I don't like this game, right? I personally have not played many more RPG, like Final Fantasy or some kind. That means that I will not include them. That doesn't mean that they are not that they are necessarily bad. Someone might will put them as their number one in top 10 list, right? What I'm trying to imply here is that if I'm trying to find the top 10 PS5 games according to everyone, then whatever the object I'm choosing, there is always a confusion regarding this inclusion and exclusion, right? Because some will say you should include it, some will say you should exclude it, right? So there is no surety, there is no, I think there is no certainty there. Okay, this will be included or excluded, like we have with alphabets. When I say an alphabet, there has to be vowel. So nobody can deny that A, E, I, O is a vowel, right? They have to accept it because that is like a certain truth, right? That is a universal kind of truth. Everybody has accepted it. But if I try to find out, let's say, top 10 PS5 games or top 10 authors or top 10 movies, right? So whenever I'm testing for that particular object, let's say games, author, or movie, uh, the inclusion or exclusion depends solely upon person, right? And it will change from person to person. That means there is a confusion, there is an ambiguity regarding this inclusion or exclusion. And that is why this collection, let's say I started with God of War, right? So I will approve it, but most people might not approve it, right? So there will be some who will approve it, there will be some who won't approve it. That means what? There is a confusion regarding it, right? There is no surety. That means that this collection is not well defined. And because it fails to be well defined, and one of the three property that a one of the two property that a collection needs to be a set, it fails that property, right? That means it's not gonna be a set. The same goes for top 10, let's say football players, or top 10 books for linear algebra, right? Because some might say some other things and they might include some other books, and some might not include those books. There is always a confusion. But when I say alphabet or when I say a natural number which lies between, I think, between 1 and 7, there is no confusion regarding it, right? Because I know that 2, 3, 4, 5, 6 are going to be those natural numbers which lie between 1 and 7. All right. So let me just tell you one more thing, I guess. So I have to check that empty, or in mathematics, we generally have this idea that what will happen if there is absence of everything, right? Let me define. Let's just simply talk. Suppose we have a collection, right? And suppose that collection is empty. What I mean by empty, I mean that the collection has no elements. So now I need to check whether a collection of no elements is a set or not, right? First of all, let me just get a new page. Let me start. I have to check collection of no elements is that or not. So this is the question. So collection of no elements is set or not, right? So just think about it. It is already a collection, right? So that is something already a tick. Now I need to check whether it is well defined, and I need to check whether the elements are distinct or not. Now, when I say well defined, that means that there should not be any confusion regarding inclusion or exclusion, right? Now, let's say any object you can think of. When you want to check for its inclusion or exclusion, you know for sure, right? That that object is not going to be part of it. That object is going to be excluded from this collection, right? Because if I include any object in the collection, then the collection will not be empty anymore, right? And we are taking only the collection of no elements. So if any object belongs to the collection, then the collection will have that object, right? But we are making a collection of no object. That means that whatever the object we are testing, that's going to be excluded. So it is well defined. So there is no confusion regarding inclusion or exclusion. Everything is going to be excluded. Now I need to make sure that whatever the elements are present in it, they are distinct. How will I claim that collection has two same elements? The only way I can claim it, if I can find two elements in the collection, and they are not distinct. Somehow I can prove they are same, right? So if I find out two objects in the collection and I find out they both are equal and they are included in and they both are included separately in the set or in the sorry in the collection, then that will simply mean that because two objects, two two separate objects, two uh, completely okay, two objects which are basically same are included in the collection. So there is at least one pair. So it's not gonna be distinct objects, right? So then the collection is not gonna be set. But the way I can claim it, if I can only find out two elements which are equal, right? The problem is because the collection has no elements in it, then I can't even find a single element. Like how will you find out two elements? And how will you prove both of them are equal? To prove both of them are equal, first you need to find them, right? And there is no way I can find them. That means that the only way I can claim that it is not distinct and thus it is not a set, it doesn't like the hypothesis that there is at least two elements that doesn't even occurs when I'm taking a collection of no elements. So what I mean by that, I mean that I won't be able to claim distinct objects either. Sorry, non-distinct objects either. That means every object that is present in it, which we know there are no objects, they are distinct because I cannot claim that they are not distinct. There is suppose so there is this basic idea that two objects are either equal or either they are not. I have just proven that I can't they are not equal. So they if they are not equal, wait a minute. They are not equal, right? So I just proven that they are not equal, right? Not equal, so they are equal. Okay. All right. So I guess I have to prove they are distinct. What I did, I just find out that the only way I can claim whether two objects are going to be distinct or not, if I can find out two elements in it and prove both of them are equal. But to claim this, I need to find at least two elements, which I can't do if the collection has no elements. That means that I can't go further with my claim that they are not distinct. That means they have to be distinct, right? So both of these conditions are true. That means this collection of no elements is a set. And this is called empty set, or you can also use null set, or you can also use void set. And the way we represent this set is by this symbol. I think it is called pi. Not pi. It is phi. Okay, it's called phi. I'm not really sure whether the spelling is right or wrong, but yeah, we pronunciate it like phi. Okay, so a collection with no elements is also in set, right? So I think this that is all for today, and I hope you learned something, and I might see you in the next class.